Okay, today's lesson is called Coordinate Proofs of Quadrilaterals, Part 1. We're going to break this into two parts because it's a lot of information. So let's get started. As you can see, I have 3 highlighters and a pencil. That's all you're going to need for this one. We're just writing down a lot of information. Oh, excuse me. Get rid of that. Okay, so it says there are 2 methods that allow us to, and the word that's going to go in there is prove quadrilaterals. The first is slope. This allows you to determine if the lines are parallel or perpendicular. The second is distance. This will allow you to determine which sides are congruent. So let's go down, and these are the 4 formulas that you're going to need to know. The slope formula, which starts with m equals, and then we go y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's also known as rise over run. Okay? The distance formula, and before I get going, each one of these formulas is dealing with 2 points. And the points we're going to call them is x1, y1, and then x2, comma, y2. So when you see y2 minus y1, what we're really doing is this y value minus that y value. x2 minus x1, this x value minus that x value. So that's what those are. They're not exponents. It's just a way to label or name a point. The distance formula is pretty extensive. It's d is equal to the square root of the quantity x2 minus x1, just like we had in the points and in the slope formula, squared, plus the quantity of y2 minus y1 squared. Now that's a pretty extensive formula. If you're given 2 sets of coordinates, that can be you can find the distance. It's a little bit challenging. What I would recommend is using the Pythagorean theorem, and the Pythagorean theorem is a squared plus b squared is equal to c squared. And you'll use a slope triangle to find the 2 sides, and then that would be the a side and the b side, and then you find c based on that. And then the last one, the midpoint formula, when we are dealing with diagonals, because they bisect each other in some, the midpoint formula would be x2 plus x1 divided by 2, and then y2 plus y1 divided by 2. Okay, so a lot goes into the x1, y1, x2, y2 with these 4 different formulas. Well, 3 out of the 4 formulas. Okay, let's move on to the next part. It says characteristics of quadrilaterals. So I'm going to highlight this because these are the characteristics of the quadrilaterals that we'll be using, all 6 of them. Parallelograms, a quadrilateral with both pairs of opposite sides, parallel, and congruent. Parallel meaning slope, congruent meaning distance. The diagonals bisect each other. So we would use midpoint there, the midpoint formula. A rhombus is a parallelogram with 4 congruent sides. So again, parallel, but instead of 2 pairs of opposite sides congruent, you got all 4. A rectangle is a parallelogram with 4 right angles. A square is a parallelogram with 4 congruent sides and 4 right angles. And these all come from the same family: parallelograms, rhombus, rectangle, and square. So just recognize that they start with a quadrilateral, then everything is based off of a parallelogram. The last one is a kite. It's a quadrilateral with 2 adjacent sides congruent and no opposite sides congruent. And then the last one is a trapezoid, and a trapezoid is a quadrilateral with exactly 1 pair of opposite sides parallel. So those are your characteristics and what goes into each one of the 6 quadrilaterals that we have. Why don't you take a moment to write those down, and then we're going to move on to the bottom. And here comes the bottom. And the bottom is, how do we prove the quadrilaterals? Okay? And there are different ways or different things that you want to look for to prove what type of a quadrilateral it is. Okay, so here we go. And when we're proving parallelograms, you want to prove that opposite sides are parallel. You're going to use slope. You want to prove that opposite sides are congruent. You want to use distance, or the Pythagorean theorem. You want to prove that diagonals bisect each other. You want to use the midpoint formula. Okay, make sure as you're writing these down, you're writing everything down that I do, because this will walk you through it. And if you have questions, you can always just look back at your notes from here. If you're proving a rhombus, you want to show it is a parallelogram. And you want to show all 4 sides congruent. Okay, and again, go back to opposite sides congruent, all 4 sides congruent. That would be your distance formula, or Pythagorean theorem. For a rectangle, you want to show opposite sides parallel, and then show there is 1 right angle. Okay? For 1 right angle, you want to show perpendicular slopes. For a square, you want to show it is a rhombus. So show that it's a parallelogram and show that all 4 sides are congruent. And then show there is 1 right angle again. And again, that would have to do with a perpendicular slope. 1 pair of perpendicular slopes. A kite is 1 pair of adjacent sides congruent, but not all 4 sides congruent. And then the last piece is a trapezoid. You want to show 1 pair of sides parallel, and then the other sides shown to not be parallel. So again, you're going to be dealing with slope here and with slope here. One congruent would be distance. So you're doing distance on the kites. Okay, whenever you see congruent means distance. Parallel, perpendicular means slopes. Okay, and I'll write that down here for you. Congruent means distance. Parallel or perpendicular means slopes. Okay, so this is your basics. I hope that helps. And get ready for part 2 of proving quadrilateral.